reaction. So now this one is all about alkanes and alkenes. So we'll discuss alkanes and alkenes. So which substance and vehicle exhaust results for incomplete combustion of a hydrocarbon fuel? That's kind of easy. That's carbon monoxide. Hopefully everyone knows that. The next one is, which compounds would be formed in the reaction of ethene with aqueous bromine in the presence of sodium chloride? Now, to answer this question, we would have to discuss the reactions of alkenes. I said the boards are still not opening in Pakistan. We still have a severe, I mean, there's an Arabian Sea issue going on. So, I mean, at my end, that is not working. But I'm going to just briefly discuss alkenes once more. We had been discussing alkenes, so just a little bit more. So alkenes had all these addition reactions. What were those addition reactions? Let's quickly go through them once more. You had alkenes. This is what an alkene looks like. It's got a double bond somewhere, and it had addition reactions. There was a reaction called bromination. What would happen in bromination was that a Br2 molecule will react at RTP, and the conditions that were used were either aqueous or you had an inert solvent. हाँ जी
सर वो मैंने कहना था कि एक क्वेश्चन आ रहा था एमसीक्यू आ रहा था उसके अंदर आ रहा था फ्री रेडिकल सब्स्टिट्यूशन
नहीं
वो क्या था
नहीं वो सारा हम डिस्कस करते हैं ठीक है तो अब वही होगा कि क्वेश्चन में ना एनीथिंग दैट कम्स आई विल जस्ट एक्सप्लेन दैट वी विल मेक नोट्स फॉर दैट एंड एनीथिंग दैट वी हैवंट डन so we did all of this, ठीक है? तभी तो fill our electrophilic addition, ठीक है? So you've got alkenes. I'll just quickly go through that. Alkenes had all these reactions that the double bond was involved, and it's the double bonded carbon atoms that would get involved, and the bromine will get added to those particular carbon atoms. This is what was happening. Then you had another reaction for alkenes, and that was hydration. That was with water. Water was in the form of steam. The temperature was 300 degrees centigrade temperature, and it was 60 atmosphere pressure, and you had phosphoric acid, which was used as a catalyst. That was a similar reaction, and in that reaction, water molecules will get added to the double bond. So you had hydrogens, and the double bond would go away and water would get added. So there's going to be an H and there's going to be an OH that would be added. So we did that as well. And there were two different products that would be formed. So you had CH3CH. So, I mean, the focus is on the double bond. This one, the one that I'm highlighting, it's all the reactions would happen with this particular double bond. So H and OH can get added in another way as well, that the OH will get added over here and the H will get added at this point. And I do remember discussing major and minor products. There was a rule, which was the Markovnikov's rule, which stated that this is considered your major product. And this was considered your minor product. Minor product has a lower probability of forming, major product has a higher probability of forming. So water gets added to the double bond. So what is the rule? How do you figure out which one is the major product? There was a rule known as the Markovnikov's rule. It's a general rule that applies to alkenes, which states that the hydrogen likes to get added. It likes to get added to the carbon in double bond, carbon in C double bond C, which is already bonded to more H atoms. So the rule simply stated that if you had an alkene, हाँ जी,
सर ये कौन सा क्वेश्चन करा रहे हैं?
नहीं तो मैं पहला वाला करा रहा हूँ ना, ये वाला. Lekin to answer that, we'll go through we will go through all the addition reactions, okay? Just one time, and then we'll move on, okay? So, As a next is, okay, you've got, one second. So next one is, Markovnikov's rule is that you've got a double bond carbon and the hydrogen, like if you have an unsymmetric alkene, the hydrogen is going to get added to the carbon that's already bonded to more H atoms. So if I look at this alkene, there are two carbons. This one is bonded to two hydrogens. There's one H over here, one H over here. And this one over here is bonded directly with just one H. So if water is going to get added, the H will likely go to the carbon that's already bonded to more H atoms. So the H is supposed to be bonded to this one, and the OH must be bonded to the other one. Okay, that's the Markovnikov's rule. It's a simple rule that you have to remember. I'll just explain the reasoning behind that as well shortly in a moment. Gigi.
सर वो थोड़ा सा unclear है, आप फिर से explain कर सकते हैं Markovnikov's rule?
नहीं, वो simply ये कि if water is getting added now, so H will get added over here and OH will get added to this one, or the other way around. The H will get added to this one and the OH will get added to this one. Though you'll get two different products, right? ये बात clear है कि you're getting two different products.
एक के ऊपर H होगा, दूसरे के ऊपर OH होगा.
हाँ, लेकिन the positions can be different, right? ये clear?
Yeah, sir.
You're either going to get propane 1 all or you're going to get propane 2 all. ठीक है, ये clear है? You're getting two different products, right? तो अब rule ये कि one of them is more likely to be formed. तो इन दोनों में से ना one of them is more likely to be formed. So water, the H that will get added, this H over here. Okay, so this H is getting added over here, that H is getting added. So H likes to get added to the carbon that's already bonded to more H atoms. This rule is simple rule. H likes to go to the carbon. This carbon has two H already. So it's already bonded to more H atoms. So H likes to go to the carbon that's already bonded to more H atoms. ये वाला जो H है ना, that's bonded to a carbon that's only bonded to one H. So जब decide करें ना, where would H go and where would OH go? Which one will get H and which one will get OH? So the H would more likely go to the carbon that's bonded to more H atoms. Is that clear?
Yes, sir.
Sir.
हाँ.
और इसके ऊपर आपने minor और major product भी लिखा हुआ है.
हाँ, तो वही major product वही है ना कि H is going to go to the carbon that's already bonded to more H atoms. The major product, this is the one that's going to form. There's a very small probability of getting the other one. ठीक है, is that clear?
सर लेकिन वो तो like 3 और 1 तो like वो तो 4 हुए और उसके साथ like bind कर, और यहाँ पे सिर्फ 2 H's हैं.
नहीं, in H को इस carbon के साथ, how many H atoms are bonded to this carbon? There's only one.
1.
उसको छोड़ दो, those H's are not with this carbon atom. ठीक है, is that clear?
Okay, sir. So
directly with, this carbon has one H, this carbon has two H's. Don't ignore those H's. Those H's are not with this carbon atom. ठीक है. So shortly, I'll discuss the reasons for that as well. And there was two more reactions. One was hydrogenation. ठीक है. So alkenes would undergo hydrogenation. Just one second. So in hydrogenation, you had a similar reaction. You had CH3, and the double bond would go away, and two H atoms will get added to the double bond position. So there's going to be an H added here, and there's going to be an H added over here. Actually, यहाँ पे you don't need to apply the Markovnikov's rule because it doesn't really matter which. I mean, both are H's. Switching their positions would have no difference at all. And what were the conditions for this? H2 plus nickel catalyst or platinum catalyst. And the temperature that was used was 150 degrees centigrade or 200 degrees centigrade. And there's a fourth reaction which was with hydrogen halides. And in that fourth reaction, your reaction was with HCl, HBr, etc., or HBr or HI. Usually it happened at RTP, or you can heat the substance, and the same thing would happen, that the alkene, the double bond would go away and So the double bond would go away, and there's going to be an H added and a Br added. So now there's going to be an issue. You're going to get two products. Either the H gets added to the left one and the Br gets added to the right one, or you're going to get the other product, which is that the H gets added to the right one and the Br gets added to the left one. So which one is the major product? The first one or the second one?
First one.
The H का क्या rule है? H wants to get added to which carbon atom?
सर जहाँ पे पहले से हाइड्रोजन से ज्यादा बॉन्डेड हो.
तो वो ये वाला है, it's this one. मतलब this is the मतलब look at the two.
Yeah, second वाला major product हो.
ठीक है, so that's your major product. That one is going to be your minor product. So major and minor products are only an issue when you have two different products getting formed. Yes.
सर ये हमारे पास किस में आ जाता है? ऑर्गेनिक केमिस्ट्री के अंदर आता है?
तो ऑर्गेनिक ही है ना, अल्कीन्स है ना, और क्या?
ओके, लाइक आगे जाके पढ़ेंगे.
नहीं, क्या चीज?
लाइक ये अभी तक लाइक हम लोगों ने लाइक पढ़ा नहीं था ये.
हाँ,
जो
लेकिन मैं वही कह रहा हूँ ना, ये अब हम पढ़ इतना रहे हैं कि हम डायरेक्ट क्वेश्चंस कर रहे हैं. And anything that is required, I'll just teach you. ठीक है? So we'll build the notes. We did alkenes, ठीक है? Because it's going to take a long time doing the theory part, and we'll miss out on the questions. More important to actually do the questions simultaneously. So I'll just go through over that. I'll teach everything about electrophilic addition. This is basically electrophilic addition that we are doing, so that we can answer that question. Once we do this, I'll just refer to the same notes over and over again. So this is electrophilic addition. Now the next thing about this is, okay, right now we're just focusing on alkanes and alkenes. So alkenes undergo electrophilic addition. These are the four reactions that that happen in electrophilic addition. Now the next part about this reaction is, now the next thing about this reaction is, you need to know the mechanism of this reaction. So we're going to talk about the mechanism of electrophilic addition. We're going to go into a bit more detail. So all those reactions that we studied above, electrophilic addition, and now we are taking a slightly deeper dive into the reactions that we just studied. So electrophilic addition mechanism. All of these are electrophilic addition. Whether it's a bromination, whether it's the reaction of water, all of them are very similar. It's the double bond that things get added to. So electrophilic addition, I'm going to do the mechanism of, let's say, one reaction. But before doing the reaction mechanism, we're going to focus on a few things. I'm going to take the simplest alkene, which is ethene. So let's take ethene. Achha, what type of hybridization does ethene have? sp3, sp2, sp1, which? Okay, that is sp2. That means both carbons are sp2 hybridized, which means that the carbon is making 3 normal bonds, sigma bonds, and one of the electrons is in a p orbital. So one of the electrons is in a p orbital. So there's one electron that is not bonding with anything. So that's an sp2 hybridized carbon atom. So that means 2 sp2 hybridized carbon atoms are basically bonded to each other. So that's one. And can I rotate this just a second? So rotate it by, so flip horizontal, I think. Okay, so that's the other carbon atom. So there are two carbon atoms. Need to correct this. This should be C. So both carbon atoms are sp2 hybridized. They would form a bond in the middle. So that's the sigma bond that they're forming. The H atoms are forming bonds on the sides. And the p orbitals are going to overlap and they would form they're going to end up forming a pi bond. Okay? Is this clear up till this point?
Yes, sir.
So there's this pi bond. Now, why is the double bond so reactive? The double bond has a very high negative charge density. When you see a double bond in a molecule in any alkene, whenever you see a double bond like this one, there's a lot of electrons over here. There's a pi bond, so there's a lot of electrons over here. And electrons will attract. So electrons are going to attract, first thing, so whenever you see a double bond, you're going to have high electron charge density. Because it's a double bond, there are too many electrons over here. And molecules will be attracted to this negative charge. But what types of molecules? Those molecules are known as electrophiles. Electrophiles are electron-loving species. Anything that's attracted to electrons, because there's a lot of electrons wherever you see a double bond, there's a lot of electrons. So molecules that will be attracted to those electrons are known as electrophiles. So these are species that are attracted, which are attracted to negative charge or electrons. Or electrons. And not only are they attracted to them, but they can also gain those electrons. I mean, there's no point if they're attracted and they're not doing anything. They're going to get attracted to those electrons and they're going to gain a pair of electrons. They're going to be reacting with them. So that's what an electrophile is. So who's attracted to electrons? Electrons, anything that's got either a positive charge or a slight positive charge or anything that is electron deficient. So there's a lot of possibilities. Lots of things have positive charges and they will be attracted to electrons. So is this clear what an electrophile is? And you should know what the definition is. It's a species that is attracted to negative charge or electrons and can gain a pair of electrons, has the capability of not only getting attracted to them, but also gaining those electrons. So first thing, the reason this reaction is electrophilic is that electrons over here, they attract electrophiles. So is that part clear? Mahal, clear? Umar, is this clear? Oswa, Raid, clear?
Sir?
हाँ जी.
सर जब वहाँ पे इलेक्ट्रॉन की चार्ज डेंसिटी ज्यादा है तो वहाँ पे तो न्यूक्लियोफाइल मतलब न्यूक्लियस वाला जो होगा वो अट्रैक्ट होगा ना?
नहीं, इलेक्ट्रोफाइल उसको कहते हैं जो इलेक्ट्रॉन से अट्रैक्ट होता है. Nucleophile is the one that's attracted to nucleus, the positive charge. Negative charge, na? There's negative charge here, right? There are electrons here.
तो
The one
सर स्ट्रॉन्ग अट्रैक्शन,
हाँ?
स्ट्रॉन्ग अट्रैक्शन जो पाई बॉन्ड में बन रहा है वो वहाँ पे लाइक होगा ना? वहाँ पे इलेक्ट्रोफाइल होंगे.
नहीं, electrophile, देखो simple सी है कि there's electrons here. Clear? There are electrons here, right?
Yes.
There's a thing over here. It could be anything. It could be anything. That thing may be something positive, right? It could be any species. Let's call it X. And it's got a slight positive charge. So this positive species is going to get attracted to those electrons. But the positive thing will get attracted to those electrons, right? Clear?
Yes, sir.
So this is an electrophile. Anything that's attracted to electrons, that's an electrophile. An electrophile doesn't mean it itself has electrons. Itself, it's electron deficient. Itself, it's positive or slight positive. But it will be attracted to electrons. That's an electrophile. Is that clear?
Yes, sir.
तो इसमें confusion हो, electrophile doesn't mean कि it has electrons. उसके पास electrons नहीं है तो वो electrons से attract हो रहा है, ठीक है? अच्छा, so next, what do I do with this? The thing is, let's do the first mechanism. Let's talk about bromination. So what's going to happen is, and you should know this mechanism in detail. So what's going to happen is that if I have an alkene, so let's start with bromination. A bromine molecule approaches it. So I've got a bromine molecule. What will happen is bromine has electrons. It's a non-polar molecule. First thing is it's a non-polar molecule. But there's so many electrons over here. Remember, there's electrons here. There's negative charge over here. So the electrons in bromine are going to be repelled. So they're going to get repelled, and this bromine will become slight negative. This bromine will become slight positive. So why are they getting repelled? Because of the negative charge over here. So the first step is that the pi bond. So the pi bond polarizes bromine molecules due to repulsion. So that is step number 1. Bromine did not have a slight positive charge. This bromine did not have a slight negative charge. But when you added bromine and mixed it with alkene, what happened is that the double bond, the electrons over here, they started repelling the electrons. These electrons over here, Jinko, let me mark them, these electrons. So they started repelling the electrons, sorry. So they started repelling the electrons over here. So due to repulsion. Is this clear? And in this way, you got a positive bromine. The positive bromine is going to be even more strongly attracted to the electrons. The negative bromine is going to be even more strongly repelled by those electrons. So at the end of the day, okay, one of the bromine is going to be repelled, and one of the bromines is going to be attracted. Hanji.
सर आपने कहा कि एक स्लाइड नेगेटिव होगा एक स्लाइड पॉजिटिव होगा वो तो समझ आ गया लेकिन जब ये इंट्रोड्यूस होते तो एल्कीन इनका फिर क्या होगा
ये क्या होगा
कि लाइक आपने कहा था कि इनके बीच में लाइक रिपल्जन हो रही होगी ना नेगेटिव चार्जेस की वजह से
नहीं पहला तो था कि उनके ऊपर कोई पॉजिटिव नेगेटिव चार्ज था ही नहीं क्योंकि वो नॉन पोलर है ब्रोमीन के ऊपर तो कोई स्लाइड पॉजिटिव स्लाइड नेगेटिव चार्ज नहीं है ना तो वो तो नॉन उसके पास आया किस तरह स्लाइड नेगेटिव स्लाइड पॉजिटिव द इलेक्ट्रॉन्स ओवर हियर दे रिपेल्ड द इलेक्ट्रॉन्स इन द ब्रोमीन बॉन्ड तो ये इलेक्ट्रॉन्स किधर पुश हो गए दे गॉट पुश्ड डाउनवर्ड साइड
यस सर
तो नीचे वाला ब्रोमीन दैट बिकेम नेगेटिव क्योंकि और ऊपर वाला ब्रोमीन दैट बिकेम स्लाइटली पॉजिटिव I mean, these electrons, who's pushing them downwards? It's the electrons over here. Okay, clear? So the alkene double bond is the one that's polarizing the bromine molecule. Is that clear?
Yes, sir.
Now, as a result, what happens is that one of the bromine has become positive and the other bromine has become negative. The positive bromine is going to act as an electrophile because it's going to be even more strongly attracted to these electrons. And the negative bromine would be even further repelled by the negative electrons over here. So one of the bromine is going to be repelled, the other bromine is going to be attracted to those electrons. Okay, so that's what's happening. Is this clear to everyone? Tanya, is this clear? Sidra?
Yes, sir. Yeah.
Okay, so the next part is, let's take this whole thing, and the next step is you've got, so what's the next step? So this bromine, the negative bromine is going to be further repelled. So it's going to be pushed away, right? So one of the bromine is going to be attracted and one of the bromines is going to be, it's going to be repelled. So the bond is going to break homolytically. So this is known as a homolytic fission. What does that mean? It means that the bond has broken unequally.
सर
हाँ
सर जब ये बोर्ड लाइक अभी तो एज ऑफ नाउ उसके अंदर लाइक मसला है, जब बोर्ड सही हो जाएगा तो तब आप करवा देंगे सर?
क्या नहीं शुरू से
ये जो लाइक नहीं नहीं, ये जो एक्सटर्नल कॉन्सेप्ट है जैसे कि होमोलिटिक फिजन, हेटेरोलिटिक और ये सारा कुछ।
नहीं ये मैं अभी करा रहा हूँ, दोबारा भी यही करना है हमने, उसको कोई नई चीज सुनी हमने, तो यही करना है। होमोलिटिक फिशन मैं अभी बता रहा हूँ कि होमोलिटिक फिशन क्या है। Homolytic fission is simply that the bond breaks unequally, which means that the two electrons, they go to one of the atom and the other atom does not get anything. ठीक है, is that clear? Okay, homolytic fission is that when you have a bond, it breaks unequally. Both electrons, they go to one atom. The other atom does not get anything. Is this clear?
Yes sir.
Sir, is that heterolytic fission?
Sorry, not that.
Yeah, it's okay.
ठीक है, that's right. This is heterolytic fission. ठीक है, I'm sorry. So that is heterolytic fission, and heterolytic fission results in the formation of ions because one atom gets both electrons. So as a result, that becomes a negative ion, the other one becomes a positive ion because the bond is breaking unequally. So always remember this. You've got two types of fissions. One of them is heterolytic and the other one is homolytic. Homolytic is one. Right now we're discussing heterolytic. I'm going to discuss homolytic when we talk about homolytic. So heterolytic is the bond breaks unequally and both electrons go to one atom. So right now, this is what's happening. A bromine molecule came to an alkene and the alkene pushed the electrons downwards and the bromine became polarized. One bromine became positively charged. One bromine became negatively charged. Because of the electrons in the double bond, the negative bromine was repelled further away and the positive bromine was attracted even more. And as a result, the bond broke. One of the bromine got pushed away and the other one, the positive one, is even more interested in those electrons. Okay? Is this clear, everyone? Is one clear? Yahan tak?
Yes sir.
So now the next part is, so once the bond breaks, now it's no longer slight positive. This is no longer slight negative. Now it's a fully positive ion. The other one is a fully. So this one is now a fully positive ion. The other one is a fully charged negative ion because the bond is no longer there. Okay? This bromine ended up with both electrons. So what will happen now? Okay? And remember, this is not the mechanism that you're going to draw in your exam. In the exam, you're going to draw a much more simplistic version. I'm just doing this for explanation purposes. So what's going to happen next? The next thing that will happen is you've got a positive bromine. It needs electrons. It sees the pi electron cloud. So what it's going to do is this positive bromine, it's going to take all that pi electron cloud. So all of that pi electron cloud is going to go away. So that pi electron cloud, it's going to take the electrons off that pi electron cloud. And that particular positive bromine is going to take all those electrons and it's going to go and bond with one of the carbon atoms. So it will take all those electrons and it will end up forming an actual bond. The positive charge on the bromine would vanish. Why would it vanish? Because it took all the electrons that were present in the pi electron cloud. And it took it and it kept it with itself. So it got its positive charge is no longer there because it now has gotten electrons. And the carbon which was previously bonding with this carbon atom is now bonding with this bromine because the electrons in the pi electron cloud have been taken up by this bromine or have been attracted by this bromine. So you've got a bond over here. So that pi bond over here, it's now a bond between these two. Is this clear?
Yes, sir.
And the other carbon gets a positive charge. Why does it get a positive charge? Because bromine took its electrons, like the pi electron cloud. Bromine took those electrons and ended up bonding with those electrons with this carbon atom. So the pi electron cloud had electrons coming from this carbon as well, but those were taken up by the bromine positive which came in. So this carbon is now positively charged, and this is known as a carbo. This is known as a carbocation. Why is it a carbocation? Because the carbon has a positive charge. So what does the carbon do with the positive charge? There's a Br minus one that had broken away earlier with taking away both electrons. So that Br minus one is going to get attracted to the carbocation. And what will happen is that the Br minus one has electrons and it will go to that carbocation and it will make a bond with it. Because the carbon is positively charged, it's electron deficient, the Br has a negative charge. So the final result is that two bromines are going to get added to the, they're going to get added. हाँ जी.
सर वो समझ आ गया कि जब उसके पास पॉजिटिव चार्ज था तो उसने लाइक पाई इलेक्ट्रॉन जो इलेक्ट्रॉन क्लाउड था उसको खत्म कर दिया.
हाँ.
पर जो ब्रोमीन है वो जो वहाँ पे कार्बोकेटाइन कैसे फॉर्म हुआ, ब्रोमीन कैसे अटैच हुआ, वो मुझे समझ नहीं आया.
नहीं मैं बता रहा हूँ एक सेकंड. नहीं ये वाला पार्ट के ये जो पहला ब्रोमीन जो अटैच हुआ था.
नहीं सर वो समझ आ गया, लेकिन जो सेकंड जो था ना जो Br-1 था और कार्बोकेटाइन फॉर्म हो गया था वो मुझे समझ नहीं आया.
तो वो तो ज्यादा आसान है कि वो पॉजिटिवली चार्ज है, दिस इज नेगेटिवली चार्ज. तो पॉजिटिव चार्ज और नेगेटिव चार्ज एक दूसरे को क्या करते हैं? डोंट दे अट्रैक्ट ईच अदर?
ओके, तो वो कार्बोकेटाइन फॉर्म करेगा.
नहीं कार्बोकैटायन तो ये बना हुआ था ना कार्बन के ऊपर. कार्बन हैड अ पॉजिटिव चार्ज राइट. वेयर डिड इट गेट, मतलब ये Br+1 आया था, दिस Br+1 ठीक है. It came in and it took all the pi electron cloud, or उन pi electron cloud को it took it and kept it with itself. ठीक है. Well, can you see my pointer?
Yes sir.
अच्छा, तो this Br took the pi electron cloud, so the carbon became electron deficient क्योंकि the pi electron cloud belonged to this carbon atom, so it got a positive charge. So this was the carbocation. Carbocation का मतलब होता है it's got a positive charge. Carbocation means the carbon's got a positive charge. Is that clear?
Yes sir.
So remember this term carbocation. That means in the molecule the carbon has a positive charge. Okay, next time Br-1 है. Br-1 was the one who got the electrons when the bond broke, right? So that Br-1 is roaming around with those electrons. Carbon needs those electrons. They're going to get attracted to this carbon and they would eventually bond together. Is that clear?
Yes.
So this is the entire mechanism of the reaction sequence. This is not the one that you're going to write in your, this is just for explanation purposes. This is not the one that you're going to write or show in your CIE. Just remember, you've got a pi electron cloud. The bromine over here is going to get polarized by that pi electron cloud. One of the bromine will become, bromine was not polar initially, but now it's polar. Why? Because who's pushing the electrons in the bond? It's the pi electron cloud, which are repelling the electrons. So this bromine became negatively charged, this bromine became positively charged. Eventually the bond would break, one of the Br would become negatively charged. It's going to be repelled even further by the pi electron cloud. The positive bromine is going to be attracted even more by the pi electron cloud. Now the final thing is one of the positive bromine is going to steal the pi electron cloud and bond with the carbon. The other carbon would become positively charged because bromine took its pi electron cloud. And how did the carbocation? The carbocation will then attract the Br-1 that was roaming around and bring it close to it and bond with it. So that's the entire process. So now we're going to write the mechanism, the CIE mechanism of this. This is what you're going to show in your exams. So this over here is a CIE mechanism. Now the CIE mechanism is it's the same one. It's pretty much the same thing. It's everything the same, but obviously a more simplistic version of this. Now, when you're writing mechanism, first thing is you should know that there's a concept of curly arrows. So make sure you learn this terminology that how do you write mechanism? Curly arrows. So this is a curly arrow. Curly arrow represents the movement of two electrons. a full curly arrow, movement of a pair of electrons, 2 electrons. Then there's another one which is a single curly, a half arrow. So that shows the movement of 1 electron, of a single electron. So there would be 2 types of arrows. So let's start. You had a double bond. Now I'm drawing the mechanism. So they're going to just make a simplistic version. You had a bromine molecule. The bromine molecule had these 2 electrons. The 2 electrons of full arrow. 2 electrons got repelled. This bromine became slightly positive. This bromine became slightly negative. The positive bromine will be attracted to those electrons, and it's going to attract the pi electron cloud. The next step is the carbon would become a carbocation because the double bond would vanish. Why? Because somebody is going to take its electrons. It's this bromine that's going to take the positive bromine, it's going to take its electrons, and a carbocation would be formed. And in the next step, so it's a pretty simple mechanism. So in the next step, the Br minus 1 is going to come back and it's going to join up with that particular carbocation. So that's, so one Br had already bonded and now this other Br is coming in. So that's about it. The middle part is known, and there are 2 steps to the reaction. There's a step 1 and there's a step number 2. Now the middle part, this is known as a carbocation intermediate. It's a carbocation intermediate that is formed. When you use the term intermediate, it means this is something that is actually formed in the reaction. It's a stable substance. You can actually stop the reaction at this point. So we'll discuss other reactions where so this, and whenever you use the term intermediate, that means it's a 2-step reaction. First, step number 1 will happen. I mean, I've written down steps. First, this thing would be formed, and then after this has formed, this other thing would be formed. So that is the Cie mechanism that's got to be remembered. And that is the general electrophilic addition. This is specifically, this is known as the electrophilic addition mechanism. And Hanji.
सर ये आपने हेटेरोलिटिक शो किया था, होमोलिटिक कैसा होगा?
वो भी करेंगे, होमोलिटिक है उसके अंदर मैं डिस्कस कर लूंगा. होमोलिटिक में वैसे मैं बता देता हूँ, होमोलिटिक is when the bond breaks equally. Like if this bond were to break equally, 1 electron would go to a hydrogen, 1 electron would go back to Cl. Is that clear?
Yes, sir.
As anyways, that's the mechanism of this reaction. Now, to answer that question, they were saying, I mean, I'll just answer this question and then we'll discuss a bit more about the mechanism. So coming back to the question was slightly complicated. They're saying that ethene is reacting with aqueous bromine, right? So this is exactly what we did over here. Ethene is reacting, this is ethene, it's reacting with aqueous bromine. This is the mechanism. But they had stated that it was reacting in the presence of NaCl. So what difference would NaCl make? If I have NaCl aqueous, that means it's going to have sodium ions and Cl ions, right? So where can the Cl ions interfere? In which step can the Cl ions interfere? Like let's say bromine
intermediate.
is okay, so Cl ions, because once a carbocation is formed, instead of the Br ions, the Cl ions could also come in and they could also get attracted to the carbocation. Is the idea clear?
Yes, sir.
Okay, so I mean, coming back to the question, the question was exactly the same: ethene reacting with bromine, and but in the presence of NaCl. Although you haven't studied, you just had to figure this out. Like, what if NaCl came in? So where can this NaCl has Cl-1 specifically? So Cl-1 is not going to go close to the double bond because electrons will repel negative charge. So I mean, initially Cl-, so Cl-1 will have nothing to do with this one. Negative double bond will repel the negative Cl-1. But once the carbocation is formed, the Cl-1 can get attracted to the carbon. So what will happen is, in the presence of NaCl, what will happen is, you will either get Br-1 bonding with the carbocation, or you'll get Cl-1 bonding with the carbocation. Is the idea clear? So you'll have two options. So instead of two Brs, you can also get a Cl in the second step, which is why the answer to this question is that you're going to get either two Brs or you're going to get one Cl. You're not going to get two Cls. If I go back to the mechanism, Cl-1 can only come in the second step. So when the second step happens, one of the Br is already in place. Once the carbocation is formed, one of the Br is already in place. So the molecule will have at least one Br. The final product will at least have one Br. Is the idea clear?
Yes, sir.
Okay. Sign clear, Ray, this is clear. Is one clearer?
Yes, sir.
Okay. So next one is so that was part of the question. So I'll just remove that. They were just asking what will happen if there is NaCl. So anyways, that's the mechanism. And let me just quickly check that the new syllabus. Just give me 1 second. The new syllabus only has. I mean, all the other mechanisms are electrophilic addition mechanisms are exactly the same. But in the new syllabus, if they have. Let me just quickly go through this. Understand, use, associate type of organic mechanism. Organic, the curly R movement. That's fine. Electrophilic. So we did electrophilic. So describe the following reactions. We did that, and yep, you only have to describe the mechanism of this one. The other ones are kind of the same. With water, it's the same. So the other one, so we're only going to discuss this one, only this one. Remember, there were 4 reactions. Like we did, where did we do the 4 reactions? Just a second. So remember, there were 4 electrophilic addition reactions, right? So the syllabus now states you just need to know the mechanism of this one. The other ones are kind of exactly the same, not much of a difference, but only this one is required. Now, another thing is that we should talk about is, I said, let's keep it to electrophilic addition. I'm going to discuss Markovnikov's rule in tomorrow's class. I said, remember, so we're going to discuss it this way. We're going to try and do questions. This pretty much covers all of electrophilic addition. So we'll, let me just go through some more questions if, where are the questions? Related to, so this one, let's just stick to alkenes for a moment. Just wanted to do. So what will happen if bromine gets is reacted with this? What will happen is that the double bonds over here will go away and a Br will get added over here and a Br will get added to this. So the double bond will turn into a single bond. Again, this double bond will turn into a single bond and bromines will get added to both carbon atoms. So it's going to be B. That's going to be your product. As anyways, if there's any other electrophilic, hydrogen bromide reacts with ethene to form bromoethane. What is the best description of the organic intermediate? It's a carbocation. Remember, alkenes, ethene, it's an electrophilic addition reaction, right? All electrophilic additions would be exactly the same. So it's going to be a carbocation. It's going to have it's going to be a carbocation.
C is the answer. C.
Yes, I was coming to that. So first thing, I'll just quickly quickly do this one. Remember the mechanism, there's a double bond. First thing is, who's going to get attracted first? H or Br? Which one is, it's already a polar molecule. So is it going to be Br getting attracted to the double bond first or H? Which one has a positive charge out of the two?
H.
Okay, so H is positive. So in this case, remember you have to be careful that the H is already positive. So it's going to be the H that will be attracted to the double bond electrons, and the Br electrons will be repelled. Okay, so the bond will break and the double bond will go away because the H is going to take. So there's going to be an intermediate and the H will take away the electrons from the double bond. So this carbon will get a positive charge. The Br is sitting somewhere with its electrons and it's going to come in and it's going to move in the next stage. So the best description about this, so Tanya, you were right that this is going to be attracted. It's a positive ion. Anything that's positive is going to be attracted to electrons. Anything that's attracted to electrons is an electrophile. So they wanted to describe this. So this is an electrophile. All the other ones were wrong. It doesn't have a negative charge. Free radical, we haven't done that. It contains carbon, hydrogen, and bromine. It doesn't, because bromine comes in the next step. The first step is that the H gets bonded to it, because the H is the one that's going to be attracted to it, not the Br. And this one is definitely an electrophile. Anything that's positive is an electrophile because it's going to be attracted to electrons. TK, is this clear?
Yes, sir.
So let's see if we can find these ones are kind of ethene reacts with aqueous bromine to give two products. This should have been added over here as well. That where's the reaction chart? Now remember, when you do bromination, but the solution is aqueous, there are chances that if it's aqueous, come back to the mechanism. If it's aqueous, what type of ions does water have? Water also has OH ions, right? Is that clear? So if the solution is aqueous and you're doing bromination, the water is going to have OH ions, and there are chances that in the second step, the carbocation might get attracted to the OH ions as well. And there could be one OH ion that would be present in the alcohol, in the bromine as well. So that is also a possibility when you have, it's a small possibility, but that is a possibility. So I'll just add this over here. That you'll have CH3C. One of them would definitely be bromine, but the other one could be OH. So this would only form if the solution is aqueous, and it's a small probability even if it's aqueous. Mostly it's going to be the first one, but there's a small probability that, because water doesn't really have a lot of OH ions, so there's a small probability that the OH ion might also interfere. Is that clear?
Yes, sir.
So he's saying which statements are correct for both products obtained in this reaction by electrophilic substitution, not its electrophilic addition, not nucleophilic addition. Both products, so the others we haven't done. We haven't done hydrolysis at the moment, so let's ignore that for now. So let's continue tomorrow then. We'll try and discuss the Markovnikov's rule, and we'll do the mechanisms of the other reactions as well. So okay, everyone, take care.
So,
हाँ जी.
सर वो जो बोर्ड है आप वो कब लाइक वहाँ पे कब स्टार्ट करेंगे?
मैंने करना तो है, मसला ये बना हुआ है कि ये जो ये बड़ी कंपनीज है ना, जैसा यूट्यूब या ये जूम वगैरह, उनके तो डिस्ट्रीब्यूटेड सर्वर्स है ना. मैं वो फिर से खोलता हूँ, एक सेकेंड. अभी जो बोर्ड्स वाली कंपनीज होती है उनके सर्वर्स एक ही जगह पड़े होते हैं, वो देखते हैं आज खुलता है कि नहीं खुलता, मैं देख लेता हूँ वैसे, क्योंकि नेट तो अभी भी अफेक्टेड है। हाँ नहीं, अगर होपफुली खुल गया एक्चुअली, नहीं इट्स वर्किंग, नहीं चलो ठीक है, विल मूव ऑन टू द बोर्ड, ठीक है, कल से विल मूव ऑन टू द
सर
बोर्ड। हाँ जी।
सर आपने जो लाइक न्यू कॉन्सेप्ट्स और जो एक्सप्लेन किए हो वहाँ पे पॉसिबल में, वो आप यहाँ पे फिर एक्सप्लेन कर सकते हैं?
कौन से सारे? तो वो उधर किए ना यार।
हाँ सर, जो होमोलिटिक, हेटेरोलिटिक, इलेक्ट्रोफाइल, न्यूक्लियोफाइल, जो आपने सारा कुछ समझाया।
हाँ नहीं, वो दोबारा करने की जरूरत क्या है, मैं कह रहा हूँ उसमें कोई इतना बड़ा कॉन्सेप्ट तो नहीं है। हेटेरोलिटिक क्या है, मतलब कोई तो इतना कोई मेजर कॉन्सेप्ट तो नहीं है, बस बॉन्ड अनइक्वली टूट रहा है और तो कुछ भी नहीं है उसमें, कि जब भी एक एटम के इलेक्ट्रॉन्स एक ही के पास चले गए तो बस वो हेटेरोलिटिक फिशन है। और मतलब इलेक्ट्रोफाइल भी कोई इतना मेजर कोई वो कॉन्सेप्ट तो नहीं है। इलेक्ट्रोफाइल तो बस ये है कि कोई भी चीज जो इलेक्ट्रॉन से अट्रैक्ट होगी वो इलेक्ट्रोफाइल है, बात खत्म बस।
हाँ, नहीं सर, वैसे लाइक कंफर्मेशन के लिए अगर पॉसिबल में कोई लाइक कॉम्प्लेक्स क्वेश्चन आ जाता है तो इसलिए।
नहीं नहीं, मैं कह रहा हूँ कॉन्सेप्ट ही कोई नहीं है ना, मतलब इसमें आप क्या समझ रहे हैं कि बस इलेक्ट्रॉन से जो चीज अट्रैक्ट हो रही है वो इलेक्ट्रोफाइल है, मतलब इस पे अब मैं और क्या,
ओके सर।
इसमें मतलब मैं कह रहा हूँ कॉम्प्लिकेशन कोई नहीं है ना, बस यही है, बस जो भी चीज तुमने कहीं भी कोई चीज इलेक्ट्रॉन से अट्रैक्ट होते हुए देख ली ना, इलेक्ट्रॉन से क्या चीज अट्रैक्ट होती है, वो खुद पॉजिटिव होगी ना, मतलब कोई पॉजिटिव चीज इलेक्ट्रॉन से अट्रैक्ट होती है ना।
यस सर।
तो मतलब वो
यस।
जो भी चीज किसी भी रिएक्शन में इलेक्ट्रॉन से या नेगेटिव चीजों के साथ अट्रैक्ट हो रही है तो वो उसको आप इलेक्ट्रोफाइल कहते हो, बात खत्म। जैसा ये अभी हमने क्वेश्चन नहीं किया था इसमें, ये वो क्या था कि बीच वाली चीज क्या होती है जो इंटरमीडिएट बना है, कार्बोकैटायन ना, तो ये पॉजिटिव चीज है ना, तो ये मुझे बताओ इलेक्ट्रॉन से अट्रैक्ट होगी कि नहीं होगी, मतलब
यस सर। होगी।
तो ये इलेक्ट्रोफाइल है, बस बात खत्म, तो इट इज एन इलेक्ट्रोफाइल। तो मैं वो कह रहा हूँ कि इतना वो कॉम्प्लिकेटेड कॉन्सेप्ट तो नहीं है, बस वो है कि न्यूक्लियोफाइल होता है जो पॉजिटिव चीजों से अट्रैक्ट होता है। अब पॉजिटिव चीजों के साथ कौन अट्रैक्ट होता है, जो खुद नेगेटिव हो, मतलब खुद नेगेटिव होगा तो इसलिए वो पॉजिटिव चीजों से अट्रैक्ट हो रहा हो, या उसके पास इलेक्ट्रॉन्स बहुत फालतू के पड़े होंगे तो उसके इलेक्ट्रॉन्स जो है ना वो किसी पॉजिटिव चीज से अट्रैक्ट हो रहे होंगे, ठीक है। मतलब ये क्या है, ये जो Br-1 है ये क्या चीज है, इलेक्ट्रोफाइल है या न्यूक्लियोफाइल है?
नेगेटिव चार्ज है तो
नहीं लेकिन ये अट्रैक्ट कैसे हो रहा है?
पॉजिटिव से हो रहा है।
तो जो पॉजिटिव से अट्रैक्ट होगा न्यूक्लियोफाइल है, ठीक है। ये जो एच है ये
ओके
क्या,
सर।
ये एच क्या है, ये क्या चीज है, एच पॉजिटिव ये क्या है?
ये इलेक्ट्रोफाइल है।
क्योंकि वो इलेक्ट्रॉन से अट्रैक्ट हो रहा है, बस बात खत्म, इतना इतनी सी चीज है। और वो जो दूसरी क्या चीज थी, अच्छा हेट्रोलिटिक, मतलब ये कौन सी फिशन हुई है, हेट्रोलिटिक हुई है ना, अनइक्वली दोनों इलेक्ट्रॉन इसी के पास चले गए, तो हेट्रोलिटिक फिशन है, ठीक है।
ओके सर।
होमोलिटिक होगा जब इलेक्ट्रॉन्स बराबर बीच में से एक उसको चला जाएगा एक उसको वापस चला जाएगा, दोनों के पास एक एक आ जाएगा। वो खैर अभी हमने, वो अक्सर होता ही नहीं है, वो होता अक्सर यही है कि इलेक्ट्रॉन जो है ना वो एक ही एटम ले जाता है, लेकिन वो होमोलिटिक हम पढ़ेंगे अभी, ठीक है, वो कल करते हैं।
ओके सर।
चलो ओके, अल्लाह हाफिज़।